Good afternoon, everyone. Today, I would like to talk about the 2001 Nobel Prize in Physics. I chose this topic because it shows how something extremely small can completely change the way we understand the world. The prize was awarded for the achievement of creating a new state of matter called a Bose-Einstein condensate. At first, this may sound very complicated. However, the basic idea is surprisingly simple. Normally, atoms move freely and behave like independent particles. Each atom has its own motion, its own energy, and its own identity. But when atoms are cooled to an extremely low temperature, very close to absolute zero, something unusual happens. Their motion slows down dramatically. As the temperature drops further, the atoms begin to lose their individuality. Instead of acting separately, they start to behave as if they were one single entity. It is as if a large group of people suddenly starts walking in perfect step, like a synchronized performance. This state is called a Bose-Einstein condensate. Why is this discovery important? Because it allows scientists to observe quantum phenomena on a scale that is easier to study. Usually, quantum effects only appear in the microscopic world. However, in this state, those effects become more visible and controllable. In other words, scientists can directly explore the strange rules of quantum mechanics. I find this discovery very fascinating. It shows that when conditions change, matter can behave in completely unexpected ways. It also teaches us that lowering energy can reveal hidden order, rather than simply reducing activity. In the future, this research may lead to new technologies such as ultra-precise sensors, advanced materials, and quantum computing. Even though this topic may seem difficult, it gives us an important message. If we look deeper into nature, we can discover new patterns and possibilities that we never imagined. Thank you. Good afternoon, everyone. Today, I would like to talk about the 2002 Nobel Prize in Physics. I chose this topic because it shows how scientists can discover invisible things and greatly expand our understanding of the universe. The prize was awarded for pioneering contributions to astrophysics, especially for the detection of cosmic neutrinos and for the discovery of cosmic X-ray sources. At first, this may sound difficult, but the basic idea is very interesting. The universe contains many objects and events that cannot be studied with ordinary visible light alone. Some of the most important information comes from signals that are extremely hard to detect. One example is the neutrino. A neutrino is an extremely small particle that interacts only very weakly with matter. Because of this, neutrinos can pass through stars, planets, and even our bodies almost without being stopped. This makes them very difficult to detect, but also very valuable for science. They can carry direct information from deep inside the sun and from violent events in space. To detect them, scientists build very large underground detectors. When a neutrino occasionally interacts with matter, it produces a tiny signal that can be observed. Another important breakthrough involved X-rays from space. Unlike visible light, X-rays reveal extremely energetic processes such as those connected with neutron stars and black holes. By detecting cosmic X-ray sources, scientists were able to study some of the most extreme regions in the universe. This prize was very important. It showed that the universe can be explored not only through ordinary light, but also through much more elusive signals. It also opened new ways to understand how stars evolve and how matter behaves under extreme conditions. I find this discovery fascinating. It shows that reality includes many important things that are completely invisible to our eyes. It also teaches us that progress in science often depends on creating new ways to observe what seemed impossible to detect. In the future, research on neutrinos and cosmic X-rays may help us understand the origin of the universe and the behavior of its most powerful objects. Even though this topic may seem abstract, it gives us an important message. The universe becomes richer and clearer when we learn how to detect what is hidden. Thank you. Good afternoon, everyone. Today, I would like to talk about the 2003 Nobel Prize in Physics. I chose this topic because it shows how matter can behave in extraordinary ways under extreme conditions. The prize was awarded for pioneering contributions to the theory of superconductors and superfluids. At first, this may sound complex, but the main idea is very interesting. Normally, when electricity flows through a material, there is resistance. This resistance causes energy to be lost as heat. However, under very low temperatures, some materials behave differently. In a state called superconductivity, electrical resistance becomes zero. This means that electricity can flow without any loss of energy. In theory, once a current starts flowing, it can continue forever without stopping. There is also a similar phenomenon called superfluidity. In this state, a liquid can flow without any friction. It can move through tiny spaces and even climb up the walls of a container. These behaviors seem almost impossible in our everyday experience. The prize recognized theoretical work that explained how many particles can act together in ordered quantum states. These contributions became central to condensed matter physics and helped scientists understand quantum fluids more deeply. This discovery is very important. Superconductors can be used in technologies such as MRI machines, high-speed trains, and efficient power transmission. Superfluids help scientists understand quantum behavior on a larger scale. I find this discovery fascinating. It shows that when conditions change, the rules we are familiar with can completely break down. It also teaches us that nature has ideal states where energy loss disappears. In the future, if superconductivity can be achieved at higher temperatures, it may revolutionize energy systems and technology. Even though this topic may seem difficult, it gives us an important message. Limits that seem natural may only exist under certain conditions. Thank you. Good afternoon, everyone. Today, I would like to talk about the 2004 Nobel Prize in Physics. I chose this topic because it helps us understand one of the deepest rules governing matter at the smallest scale. The prize was awarded for the discovery of asymptotic freedom in the theory of the strong interaction. At first, this may sound very abstract, but the idea is actually quite surprising. Matter is made of atoms, and atoms contain nuclei. Inside the nucleus, there are protons and neutrons. If we look even deeper, we find that protons and neutrons are made of smaller particles called quarks. Quarks are held together by the strong interaction, which is one of the fundamental forces of nature. This force is responsible for binding quarks together inside larger particles. What made this discovery so important was a very unusual property called asymptotic freedom. Normally, we expect particles to interact more strongly when they get closer together. However, quarks behave differently. When quarks are extremely close to one another, they interact more weakly and can move almost freely. But when scientists try to pull them apart, the force becomes stronger. This explains why quarks are never observed alone in ordinary conditions. They remain confined inside particles such as protons and neutrons. This discovery was very important. It provided a deeper theoretical foundation for modern particle physics. It also helped scientists understand how matter is structured at the most fundamental level. I find this discovery fascinating. It shows that nature does not always behave according to simple everyday intuition. It also teaches us that the deepest rules of the universe can be both elegant and surprising. In the future, this understanding may continue to help physicists explore the early universe and the behavior of matter under extreme conditions. Even though this topic may seem difficult, it gives us an important message. The closer we examine reality, the more unexpected its structure becomes. Thank you. Good afternoon, everyone. Today, I would like to talk about the 2005 Nobel Prize in Physics. I chose this topic because it shows how a deeper understanding of light can lead to extremely precise ways of measuring nature. The prize was awarded for contributions to the quantum theory of optical coherence and for the development of laser-based precision spectroscopy, including the optical frequency comb technique. At first, this may sound technical, but the central idea is very exciting. Light is not only something that helps us see the world, it can also be used as a highly precise tool for measurement. One important concept is optical coherence. This refers to the orderly and stable behavior of light waves. When light is highly coherent, it can be controlled with great precision. That is why lasers are so useful in science. A laser produces light that is far more organized than ordinary light. Because of this, scientists can use it to study atoms and molecules with extraordinary accuracy. Another major breakthrough was the development of the optical frequency comb. This technique allows scientists to measure light frequencies very precisely, almost like using a ruler for light. With this method, researchers can compare frequencies with remarkable accuracy. As a result, they can test physical laws, improve atomic clocks, and analyze matter in great detail. This discovery was very important. It opened a new level of precision in spectroscopy and measurement. It also connected the study of light with some of the most accurate technologies in modern science. I find this discovery fascinating. It shows that progress in physics does not always come from building larger machines, but sometimes from measuring nature more precisely. It also teaches us that precision itself can reveal new truths about the universe. In the future, these techniques may improve timekeeping, navigation, environmental measurement, and tests of fundamental physics. Even though this topic may seem advanced, it gives us an important message. When we measure the world more accurately, we can understand it more deeply. Thank you. Good afternoon, everyone. Today, I would like to talk about the 2006 Nobel Prize in Physics. I chose this topic because it helps us understand how the universe began and how we can study its earliest state. The prize was awarded for the discovery of the blackbody form and anisotropy of the cosmic microwave background radiation. At first, this may sound very complex, but the idea is quite fascinating. Scientists believe that the universe began with the Big Bang. However, we cannot directly observe that moment. So how can we learn about the early universe? The answer lies in the cosmic microwave background radiation. This radiation is a faint signal that fills the entire universe. It is considered the afterglow of the Big Bang. Although it is very weak, it carries important information. Scientists discovered that this radiation is almost uniform, but not perfectly. There are tiny differences in temperature across space. These small variations are extremely important. They show how matter was distributed in the early universe. Over time, these small differences grew into stars, galaxies, and large cosmic structures. This discovery was very important. It provided strong evidence for the Big Bang theory. It also allowed scientists to study the origin of the universe with high precision. I find this discovery very fascinating. It shows that even very small signals can contain information about something enormous. It also teaches us that the past leaves traces that we can still observe today. In the future, this research may help us understand the origin and evolution of the universe even more deeply. Even though this topic may seem abstract, it gives us an important message. The universe itself is a record of its own history. Thank you. Good afternoon, everyone. Today, I would like to talk about the 2007 Nobel Prize in Physics. I chose this topic because it shows how advances in physics can directly impact everyday technology. The prize was awarded for the discovery of giant magnetoresistance, often called GMR. At first, this may sound difficult, but the idea is actually quite simple. Magnetoresistance refers to the change in electrical resistance when a magnetic field is applied. Scientists discovered that in certain layered materials, this effect becomes extremely large. This phenomenon is called giant magnetoresistance. Why is this important? Because it made it possible to read very small magnetic signals with high precision. This had a huge impact on data storage technology. For example, hard disk drives store information using tiny magnetic regions. Before GMR, it was difficult to read these signals accurately when they became very small. However, GMR sensors allowed much more sensitive detection. As a result, the storage capacity of hard drives increased dramatically. This means that we can store more data in smaller devices. I find this discovery very fascinating. It shows how fundamental physics can lead to practical innovations. It also teaches us that improving measurement accuracy can change entire industries. In the future, similar technologies may lead to even more advanced data storage and electronic devices. Even though this topic may seem technical, it gives us an important message. Better ways of reading information can transform the world. Thank you. Good afternoon, everyone. Today, I would like to talk about the 2008 Nobel Prize in Physics. I chose this topic because it shows how very small particles can reveal deep truths about the structure of the universe. The prize was awarded for the discovery of the mechanism of spontaneous broken symmetry in subatomic physics, and for the discovery of the origin of the broken symmetry that predicts the existence of at least 3 families of quarks. At first, this may sound extremely difficult, but the main idea is very important. In physics, symmetry means that the laws of nature remain the same under certain changes. For a long time, scientists believed that these symmetries were exact and universal. However, later research showed that nature does not always preserve symmetry in a perfect way. One important idea is spontaneous symmetry breaking. This means that the basic laws may be symmetrical, while the actual state of a system is not. In other words, nature can begin with balance but end with an uneven result. This idea became very important in subatomic physics. It helped scientists understand how particles can behave differently, even when the underlying laws look elegant and balanced. The second part of the prize concerned broken symmetry in the behavior of quarks. Quarks are fundamental particles that make up protons, neutrons, and many other particles. Scientists discovered that the origin of this broken symmetry could be explained only if there were at least 3 families of quarks. This idea was developed by Makoto Kobayashi and Toshihide Masukawa. Their theory showed that the known particles were not enough to explain the observed asymmetry. As a result, the existence of additional quark families became necessary. This was a remarkable prediction, and later experiments supported it. This discovery was extremely important. It helped explain CP violation, which means that matter and antimatter do not behave in exactly the same way. It also gave scientists a possible clue to one of the biggest questions in cosmology. Why is the universe made mostly of matter, even though matter and antimatter should have been created together? I find this discovery very fascinating. It shows that even slight asymmetries in the smallest particles can influence the history of the entire universe. It also teaches us that elegant theories become powerful when they can predict things that are later confirmed. In the future, this line of research may help us understand the origin of matter and the structure of the universe more deeply. Even though this topic may seem abstract, it gives us an important message. A small imbalance in nature can shape the world on the largest scale. Thank you. Good afternoon, everyone. Today, I would like to talk about the 2009 Nobel Prize in Physics. I chose this topic because it shows how modern communication and imaging technologies work. The prize was awarded for achievements in optical fiber communication and the invention of the CCD sensor. At first, this may sound technical, but it is closely related to our daily lives. Optical fibers are used to transmit information as light signals. These fibers allow data to travel over long distances with very little loss. This technology supports the internet and global communication. Without it, modern society would not function as it does today. The second part of the prize is the CCD sensor. This device converts light into electrical signals. It is used in digital cameras and many imaging systems. For example, when you take a photo with your smartphone, the CCD sensor captures the image. Together, these technologies are very important. Optical fibers send information, and CCD sensors receive and convert it. They form the foundation of modern information systems. I find this discovery very fascinating. It shows how information can be transmitted and captured efficiently. It also teaches us that communication depends on both sending and receiving. In the future, these technologies may become even more advanced. Even though this topic may seem technical, it gives us an important message. Information systems require both transmission and detection. Thank you. Good afternoon, everyone. Today, I would like to talk about the 2010 Nobel Prize in Physics. I chose this topic because it shows how simple structures can lead to powerful properties. The prize was awarded for groundbreaking experiments regarding graphene. Graphene is a very special material. It consists of a single layer of carbon atoms arranged in a hexagonal pattern. This means it is only one atom thick. Even though it is extremely thin, graphene is very strong. It is also an excellent conductor of electricity. In addition, it has unique electronic properties that are different from other materials. At first, scientists believed that such a thin material could not exist stably. However, experiments proved that graphene can exist and be studied. This discovery was very important. It opened a new field of research in materials science. Graphene may be used in electronics, energy storage, and many other applications. For example, it could lead to faster computers and more efficient batteries. I find this discovery very fascinating. It shows that reducing something to its simplest form can reveal new possibilities. It also teaches us that new properties can emerge at extreme scales. In the future, graphene may transform many technologies. Even though this topic may seem scientific, it gives us an important message. Simplicity can lead to powerful innovation. Thank you. Good afternoon, everyone. Today, I would like to talk about the 2011 Nobel Prize in Physics. I chose this topic because it reveals something surprising about the universe. The prize was awarded for the discovery that the expansion of the universe is accelerating. At first, scientists believed that the expansion of the universe would slow down over time. This idea made sense because gravity pulls matter together. However, observations showed the opposite. The universe is not slowing down. It is expanding faster and faster. This discovery was made by studying distant supernovae. These exploding stars act as standard candles that help measure distance. Scientists found that distant supernovae were farther away than expected. This means the expansion of the universe has been accelerating. To explain this, scientists proposed the existence of dark energy. Dark energy is a mysterious force that drives the acceleration. It makes up most of the energy in the universe. This discovery was very important. It changed our understanding of the universe. It showed that unknown forces can dominate large systems. I find this discovery very fascinating. It shows that the universe behaves in unexpected ways. It also teaches us that our assumptions can be wrong. In the future, scientists hope to better understand dark energy. Even though this topic may seem abstract, it gives us an important message. Systems can evolve in ways we do not expect. Thank you. Good afternoon, everyone. Today, I would like to talk about the 2012 Nobel Prize in Physics. I chose this topic because it shows how scientists can control individual quantum systems. The prize was awarded for groundbreaking experimental methods that enable measuring and manipulation of individual quantum systems. At first, this may sound difficult, but the idea is very important. Quantum systems, such as atoms and particles, are extremely small. For a long time, scientists could only study them in large groups. However, new techniques made it possible to observe and control single particles. For example, scientists can trap ions or photons and manipulate them with great precision. This allows them to study quantum behavior directly. This discovery was very important. It opened the door to quantum computing and advanced technologies. By controlling individual quantum states, scientists can process information in new ways. This could lead to powerful computers that solve complex problems. I find this discovery very fascinating. It shows that even the smallest elements can be controlled and studied. It also teaches us that precision at a tiny scale can lead to major technological advances. In the future, quantum technologies may transform computing and communication. Even though this topic may seem abstract, it gives us an important message. Control at the smallest level can create powerful systems. Thank you. Good afternoon, everyone. Today, I would like to talk about the 2013 Nobel Prize in Physics. I chose this topic because it explains one of the most fundamental questions in physics: why particles have mass. The prize was awarded for the theoretical discovery of a mechanism that contributes to our understanding of the origin of mass of subatomic particles. This mechanism is known as the Higgs mechanism. According to modern physics, particles are described by quantum fields. These fields exist everywhere in space. However, one important question remained unanswered for a long time. Why do some particles have mass, while others do not? The Higgs mechanism provides an explanation. It proposes the existence of a field called the Higgs field, which fills all space. When particles interact with this field, they acquire mass. In other words, mass is not simply an intrinsic property of particles. It arises from their interaction with the Higgs field. This idea was first proposed in the 1960s. For decades, scientists searched for experimental evidence. In 2012, researchers at CERN confirmed the existence of a new particle consistent with the Higgs boson. This discovery provided strong support for the theory. The Higgs mechanism is a key part of the standard model of particle physics. It helps explain how the fundamental structure of matter is formed. I find this discovery very fascinating. It shows the properties we take for granted, such as mass, have deeper origins. It also demonstrates the importance of combining theory and experiment. In the future, further research may deepen our understanding of the universe. Even though this topic may seem abstract, it gives us an important message. The visible world is shaped by invisible structures. Thank you. Good afternoon, everyone. Today, I would like to talk about the 2014 Nobel Prize in Physics. I chose this topic because it shows how a scientific breakthrough can directly improve our daily lives. The prize was awarded for the invention of efficient blue light-emitting diodes, or blue LEDs. Light-emitting diodes were already known, but creating blue light was very difficult. Red and green LEDs had been developed earlier, but without blue light, it was impossible to produce white light efficiently. The invention of blue LEDs solved this problem. By combining red, green, and blue light, scientists were able to create bright white light. This led to the development of energy-efficient lighting systems. Compared to traditional light bulbs, LED lighting consumes much less energy and lasts much longer. This discovery has had a significant impact on society. It has reduced energy consumption worldwide and contributed to environmental protection. It is also widely used in displays, smartphones, and televisions. I find this discovery very interesting because it shows how fundamental research can lead to practical applications. It also demonstrates the importance of persistence in scientific research. For many years, scientists struggled to develop blue LEDs, but they did not give up. In the future, this technology may continue to evolve and improve energy efficiency even further. Even though this topic may seem simple, it gives us an important message. Innovation can transform everyday life. Thank you. Good afternoon, everyone. Today, I would like to talk about the 2015 Nobel Prize in Physics. I chose this topic because it reveals that even fundamental particles can change their identity. The prize was awarded for the discovery of neutrino oscillations, which shows that neutrinos have mass. Neutrinos are extremely small particles that rarely interact with matter. For a long time, scientists believed that neutrinos had no mass. However, experiments showed something unexpected. Neutrinos can change from one type to another as they travel. This phenomenon is called neutrino oscillation. There are three types, or flavors, of neutrinos: electron, muon, and tau. As neutrinos move through space, they can transform between these types. This behavior can only occur if neutrinos have mass. Therefore, this discovery changed our understanding of particle physics. It showed that the standard model was incomplete. This finding has important implications for our understanding of the universe. Neutrinos are very abundant and play a role in cosmic processes. I find this discovery very fascinating because it shows that even the smallest particles are not fixed. It also teaches us that change is a fundamental property of nature. In the future, further research may reveal more about the role of neutrinos in the universe. Even though this topic may seem abstract, it gives us an important message. Nothing is completely unchanging. Thank you. Good afternoon, everyone. Today, I would like to talk about the 2016 Nobel Prize in Physics. I chose this topic because it introduces a new way of understanding matter based on topology. The prize was awarded for theoretical discoveries of topological phase transitions and topological phases of matter. Traditionally, phases of matter are classified by symmetry and order. For example, solids, liquids, and gases are distinguished by how their particles are arranged. However, this discovery introduced a different perspective. It showed that some properties of materials depend not on local detail, but on global structures. This idea comes from topology, a branch of mathematics that studies properties that remain unchanged under continuous deformation. For example, a coffee cup and a donut are considered equivalent in topology because both have one hole. In certain materials, electrons behave in ways that are protected by topological properties. This means that their behavior remains stable even when the material is disturbed. Such materials are called topological insulators and superconductors. These materials have unique electrical properties and may be useful in future technologies. This discovery has opened a new field in physics. It has changed how scientists classify and study matter. I find this discovery very fascinating because it shows that structure can determine behavior in unexpected ways. It also teaches us that global patterns can be more important than local details. In the future, this research may lead to new technologies, including quantum computing. Even though this topic may seem abstract, it gives us an important message. The shape of a system can define its function. Thank you. Good afternoon, everyone. Today, I would like to talk about the 2017 Nobel Prize in Physics. I chose this topic because it represents a completely new way of observing the universe. The prize was awarded for decisive contributions to the LIGO detector and the observation of gravitational waves. Gravitational waves are ripples in the fabric of space-time. They were first predicted by Albert Einstein in his general theory of relativity in 1915. For a long time, scientists believed that detecting them would be extremely difficult. This is because gravitational waves are incredibly weak by the time they reach Earth. To detect them, scientists developed LIGO, which stands for the Laser Interferometer Gravitational Wave Observatory. LIGO is a giant interferometer that uses laser beams to measure extremely tiny changes in distance. When a gravitational wave passes through Earth, it stretches space in one direction and compresses it in another. LIGO can detect these minute changes with extraordinary precision. In 2015, researchers used LIGO to make the first direct observation of gravitational waves. These waves were produced by the merger of two black holes. This was a historic achievement. It confirmed Einstein's prediction after about 100 years. It also opened a completely new field of astronomy. Instead of observing only light, scientists can now study the universe through gravitational waves. This allows us to detect violent cosmic events that may be invisible to ordinary telescopes. For example, black hole mergers cannot usually be seen directly with light. However, they can be detected clearly through gravitational waves. This discovery has greatly expanded our understanding of astrophysics and the universe. It also shows how advanced instruments can turn a theoretical idea into an observed reality. I find this discovery very fascinating. It shows that new tools can reveal parts of nature that were hidden for centuries. It also teaches us that scientific progress often depends not only on ideas, but also on the invention of instruments precise enough to test them. In the future, gravitational wave astronomy may reveal many more hidden events in the universe. Even though this topic may seem abstract, it gives us an important message. When science develops new ways of observing reality, the universe becomes much larger and richer than we once imagined. Thank you. Good afternoon, everyone. Today, I would like to talk about the 2018 Nobel Prize in Physics. I chose this topic because it shows how light can be controlled to manipulate matter at extremely small scales. The prize was awarded for groundbreaking inventions in the field of laser physics. Lasers produce highly focused and intense beams of light. By controlling these beams, scientists can interact with matter in very precise ways. One important development is optical tweezers. Optical tweezers use laser light to trap and move tiny particles. This allows scientists to study biological molecules such as DNA and proteins. Another important innovation is the generation of extremely short and powerful laser pulses. These pulses are so brief that they can capture events occurring in a fraction of a second. They are also intense enough to interact with electrons. This technology makes it possible to study ultra-fast processes in physics and chemistry. It has opened new possibilities in scientific research. For example, scientists can now observe how electrons move within atoms. This discovery has also led to practical applications in medicine and industry. I find this discovery very fascinating because it shows how light can be used as a tool to control matter. It also teaches us that precision is essential in modern science. In the future, laser technology may become even more advanced. Even though this topic may seem technical, it gives us an important message. Control at small scales leads to powerful results. Thank you. Good afternoon, everyone. Today, I would like to talk about the 2019 Nobel Prize in Physics. I chose this topic because it helps us understand both how the universe developed and where Earth stands within it. The prize was awarded for contributions to our understanding of the evolution of the universe and Earth's place in the cosmos, including theoretical discoveries in physical cosmology and the discovery of an exoplanet orbiting a solar-type star. At first, this topic may sound very broad, but the main idea is clear. One part of the prize recognized theoretical discoveries in physical cosmology. Physical cosmology is the study of the universe as a whole, including how it began, how it evolved, and how large-scale structures formed. Scientists developed theoretical models that helped explain the early universe after the Big Bang. They studied how tiny fluctuations in matter and energy could grow over time. These small differences eventually led to the formation of galaxies, clusters of galaxies, and the large-scale structure of the universe. This work was extremely important because it connected the laws of physics with the history of the cosmos. It showed that the universe did not develop randomly. Instead, its evolution followed physical principles that can be studied and described mathematically. This gave us a much deeper understanding of how the universe changed from a hot, nearly uniform state into the rich cosmic structure we observe today. The second part of the prize concerned the discovery of an exoplanet orbiting a solar-type star. This was the first confirmed discovery of a planet around a star like our Sun. Before this finding, scientists did not know whether planetary systems like our own were common in the universe. The discovery showed that our solar system is not necessarily unique. It also changed the way we think about Earth's place in the cosmos. Together, these discoveries were very important. Theoretical work in physical cosmology helped explain how the universe evolved, while the discovery of an exoplanet around a solar-type star showed that Earth exists within a much broader cosmic setting. I find this Nobel Prize very fascinating. It shows that science can help us understand both the history of the universe and our own position within it. It also teaches us that theory and observation work best when they support each other. In the future, this line of research may help us understand the universe even more deeply and perhaps discover more worlds like our own. Even though this topic may seem distant, it gives us an important message. The more we learn about the universe, the better we understand ourselves within it. Thank you. Good afternoon, everyone. Today, I would like to talk about the 2020 Nobel Prize in Physics. I chose this topic because it deals with one of the most mysterious objects in the universe: black holes. The prize was awarded for discoveries related to black holes. A black hole is a region in space where gravity is so strong that nothing, not even light, can escape. For a long time, black holes were only theoretical objects. Scientists were not sure whether they actually existed. One part of the prize recognized theoretical work that showed black holes are a natural consequence of Einstein's general theory of relativity. This research demonstrated that when a massive star collapses under its own gravity, it can form a black hole. This idea helped establish black holes as real physical objects, not just mathematical predictions. The other part of the prize was awarded for the discovery of a supermassive black hole at the center of our galaxy. Scientists observed the motion of stars near the center of the Milky Way. They found that these stars were moving in extremely fast and unusual orbits. The only explanation for this motion was the presence of a very massive and invisible object. This object was identified as a black hole. This discovery provided strong evidence that black holes exist in reality. It also showed that many galaxies, including our own, contain supermassive black holes at their centers. I find this discovery very fascinating because it connects theory and observation in a powerful way. It shows how abstract ideas in physics can lead to real discoveries in space. In the future, further research may help us understand black holes in more detail. Even though black holes seem distant, they play an important role in the structure of the universe. This award reminds us that the universe still holds many mysteries waiting to be explored. Thank you. Good afternoon, everyone. Today, I would like to talk about the 2021 Nobel Prize in Physics. I chose this topic because it deals with complex systems and how we can understand them using physics. The prize was awarded for groundbreaking contributions to our understanding of complex physical systems. One part of the prize focused on Earth's climate system. Climate is a complex system because it involves many interacting components, such as the atmosphere, oceans, land, and ice. These components influence each other in complicated ways, making long-term predictions difficult. Scientists developed models that describe how carbon dioxide affects global temperature. They showed that increasing levels of carbon dioxide in the atmosphere lead to a rise in global temperatures. This work provided a clear scientific basis for understanding climate change. It also allowed scientists to make more accurate predictions about future climate conditions. The other part of the prize focused on disordered systems in physics. These systems include materials such as glasses and spin systems, where the structure is not regular or predictable. At first glance, these systems seem random and difficult to analyze. However, scientists discovered that even these complex systems follow certain underlying rules. They developed mathematical methods to describe how disorder and randomness can still produce stable patterns. This work has applications not only in physics, but also in fields such as biology, neuroscience, and even machine learning. I find this discovery very interesting because it shows that complexity does not mean complete randomness. Instead, hidden structures and patterns can exist within complex systems. This idea helps us better understand natural phenomena, from climate change to brain activity. In the future, these methods may help scientists solve other complex problems. For example, they could improve weather prediction, materials science, and artificial intelligence. Even though complex systems are difficult to study, they are essential to understanding the real world. This award reminds us that physics is not only about simple systems, but also about complexity and uncertainty. Thank you. Good afternoon, everyone. Today, I would like to talk about the 2022 Nobel Prize in Physics. I chose this topic because it deals with one of the most fundamental questions in science: how nature behaves at the quantum level. The prize was awarded for experiments with entangled photons, establishing the violation of Bell inequalities, and pioneering quantum information science. Quantum mechanics describes the behavior of particles at extremely small scales, such as atoms and photons. One of its most surprising features is quantum entanglement. Entanglement is a phenomenon in which two particles become linked in such a way that the state of one particle is directly related to the state of another, even if they are far apart. This idea challenged classical physics, which assumes that objects have independent properties. To test this concept, scientists conducted experiments based on Bell's theorem. Bell's theorem provides a way to determine whether the predictions of quantum mechanics are correct or whether hidden variables could explain the results. Experiments with entangled photons showed that Bell inequalities are violated. This means that the results cannot be explained by classical physics or hidden variables. Instead, they confirm the strange predictions of quantum mechanics. These experiments demonstrated that reality at the quantum level is fundamentally different from our everyday experience. The research also laid the foundation for quantum information science. This field includes technologies such as quantum computing, quantum cryptography, and quantum communication. For example, quantum entanglement can be used to create secure communication systems that are theoretically impossible to hack. Quantum computers may solve certain problems much faster than classical computers. I find this discovery very fascinating because it challenges our intuitive understanding of reality. It shows that nature behaves in ways that are not always predictable using classical logic. In the future, quantum technologies may transform computing, communication, and data security. Even though quantum phenomena are difficult to understand, they are becoming increasingly important in modern science and technology. This award reminds us that exploring fundamental questions can lead to revolutionary applications. Thank you. Good afternoon, everyone. Today, I would like to talk about the 2023 Nobel Prize in Physics. I chose this topic because it explores how we can observe extremely fast processes that occur on the scale of electrons. The prize was awarded for experimental methods that generate attosecond pulses of light for the study of electron dynamics in matter. An attosecond is an incredibly short unit of time. It is 1/quintillionth of a second, or 10 to the negative 18 seconds. At this timescale, electrons move within atoms and molecules. Understanding electron motion is essential because it forms the basis of chemical reactions and physical processes. However, for a long time, it was impossible to directly observe such rapid movements. Scientists developed techniques to produce extremely short pulses of light, known as attosecond pulses. These pulses act like ultra-fast cameras that can capture electron motion in real time. To generate these pulses, researchers used high-intensity laser fields. When a laser interacts with atoms, it can produce high-energy light in very short bursts. By carefully controlling this process, scientists were able to create attosecond pulses. Using these pulses, researchers can study how electrons move and how they respond to external forces. This provides detailed insight into processes such as ionization and energy transfer. The ability to observe electron dynamics opens new possibilities in science. For example, it can improve our understanding of chemical reactions and material properties. It may also lead to advances in electronics and photonics. I find this discovery very fascinating because it allows us to observe events that were previously invisible. It shows how advances in technology can push the limits of human knowledge. In the future, attosecond science may lead to new techniques for controlling electron behavior. This could result in faster electronic devices and more efficient energy systems. Even though these processes occur at an extremely small scale, they have a significant impact on the world around us. This award reminds us that studying the smallest scales can lead to the biggest discoveries. Thank you. Good afternoon, everyone. Today, I would like to talk about the 2024 Nobel Prize in Physics. I chose this topic because it shows how ideas from physics helped create powerful tools for machine learning. The prize was awarded for foundational discoveries and inventions that enable machine learning with artificial neural networks. At first, this topic may sound more like computer science than physics. However, the key ideas are deeply connected to physical systems and the way complex patterns can be stored and processed. One important part of the prize concerned the work of John Hopfield. He developed a network, now called the Hopfield network, that can store and recover patterns. For example, even if some information is incomplete or noisy, the network can still recognize the original pattern. This is possible because the system moves toward a stable state, much like a physical system seeking a lower energy configuration. In this way, the Hopfield network showed that ideas from physics could be used for pattern recognition and memory. The second major part of the prize concerned Geoffrey Hinton. He helped develop methods that allowed artificial neural networks to learn from data more effectively. His work made it possible for networks to identify patterns, classify information, and improve their performance through training. This became one of the foundations of modern machine learning. Artificial neural networks are inspired by the structure of the brain. They consist of connected units that process information together. By adjusting the strength of these connections, the system can learn to recognize images, understand language, and make predictions. This discovery was extremely important. It showed that machine learning with artificial neural networks could be built on fundamental scientific principles. It also created the foundation for many of the AI systems that are now used in science, medicine, and everyday technology. I find this discovery very fascinating. It shows that ideas developed in physics can influence completely new fields. It also teaches us that understanding complex systems can lead to tools that change the world. In the future, artificial neural networks may become even more powerful and useful. Even though this topic may seem modern, it gives us an important message. Basic scientific ideas can lead to revolutionary new technologies. Thank you. Good afternoon, everyone. Today, I would like to talk about the 2025 Nobel Prize in Physics. I chose this topic because it shows that quantum mechanics can appear not only in atoms, but also in electrical circuits large enough to be engineered and measured directly. The prize was awarded for the discovery of macroscopic quantum mechanical tunneling and energy quantization in an electric circuit. At first, this topic may sound surprising. Quantum mechanics is usually associated with extremely small particles, such as electrons, atoms, or photons. For a long time, many scientists thought that quantum effects could not be observed clearly in larger systems. However, research on superconducting electric circuits showed that this was not true. These circuits are made from superconducting materials, which allow electric current to flow without resistance at very low temperatures. Under these conditions, the circuit can behave according to quantum rules. One important discovery was macroscopic quantum mechanical tunneling. In classical physics, a system should not be able to cross an energy barrier if it does not have enough energy. However, quantum mechanics allows tunneling, which means that a system can pass through a barrier anyway. What made this discovery remarkable was that the effect was observed in an electric circuit large enough to be treated as a macroscopic object. The second important discovery was energy quantization in an electric circuit. In classical physics, energy can usually vary continuously. In quantum systems, however, only certain discrete energy levels are allowed. Scientists showed that superconducting circuits can have such quantized energy states. This meant that an electric circuit could behave like an artificial quantum system, with well-defined energy levels that can be studied experimentally. These discoveries were extremely important. They showed that quantum mechanics is not limited to the microscopic world. They also made it possible to design and control superconducting circuits for further research. This work laid part of the foundation for modern quantum technology. For example, superconducting circuits are now used in qubits for quantum computing. I find this discovery very fascinating. It shows that ideas once thought to belong only to the atomic world can also appear in larger human-made systems. It also teaches us that the boundary between the classical world and the quantum world is more subtle than we once believed. In the future, this research may lead to more advanced quantum devices for computing, sensing, and communication. Even though this topic may seem highly technical, it gives us an important message. Quantum physics does not disappear simply because a system becomes larger. Under the right conditions, it can still reveal itself in powerful and surprising ways. Thank you.